today's video we'll look at change of variables in multiple integrals. This theorem says that we change from sy to an integral in u and v by expressing s and y in terms of u and v and writing the a, which is simply the Jacobian of transformation multiplied by du dv. So this whole guy is the a. This whole guy is the a. So we take an example on it. An example, we are told to evaluate this double integral where R is the trapezoidal region with vertices given by 0, 0, 5, 0, 5, 5 over 2, 5 over 2, and this using the transformation s equals to 2u plus 3v and y equals to 2u minus 3v. So we are going to use this transformation s and y express or have a boundary of u and v. So we can just plug in our interval for u and v here and evaluate our integral. And we are going to express s and y in terms of u and v. And the a as this, which is absolute value of Jacobian of sy with respect to u and v times du dv. So all our integrands, they are going to be in terms of u and v. In our Jacobian, we are going to use this transformation s and y by differentiating s with respect to u and v and y with respect to u and v also. So this is the formula for this Jacobian transformation. So we're gonna have partial s y with respect to u and v, which is partial s, partial u, partial s, partial v, partial s, partial y, partial u, partial y, partial v. This is our x. We differentiate with respect to u, we're gonna have 2u, we're gonna have 2. We differentiate this guy with respect to v, we're gonna have 3. The same thing with this, we're gonna have partial y, partial u is simply 2, and partial y, partial v is minus 3. So we are going to plug in our value for the Jacobian here. These are partial s, partial u. We're gonna have 2. Partial s, partial v, we're gonna have 3. Partial y, partial u, that's 2. And this guy minus 3. So this minus 6 minus 6, that's minus 12. But note that from here, this is simply absolute value, not determinant, just absolute value. So we take the absolute value of our Jacobian. So we have 12. Therefore, our dA, which is simply this guy, is just 12 du dv. So now we're gonna have an interval for our u and v, so we can evaluate our integral given. The interval for u and v, we are going to use the vertices given, all these vertices given. So we have s is equals to 2u plus 3v and y equals 2u minus 3v. Taking the first vertex, which is this. This is simply x, this is y. When s is 0, so we have 2u plus 3v equals 0. When y is 0, we have 2u minus 3v equals to 0. When we add these two guys together, we're going to have 4u equals 0, which is simply u equals to 0. Taking another vertex, which is 5, 0. So we have 5, 0. This is y. When n is 0, when n is 5 rather, we have 2u plus 3v equals 5. And when y is 0, we have 2u minus 3v equals 0. So when we add these two guys together, we're going to have 4u equals 5, which is u equals to 5 over 4. So we can conclude that u lies between 0 and 5 over 4, because 0 is strictly less than 5 over 4. If you do the same thing to this vertex and this vertex, you're going to have 0 and 5 over 4 as we obtained here. So this question 1. Now to obtain interval for v. From this equation, this and this, when we subtract this from this, so we're going to have, that will be 3v, 2u minus 2, that's 0, 3v minus 3, that's 6v. So we have 6v equals 0. So we have 6v equals 0, so v equals 0. Also, from these two equations, when we subtract this guy from this, we're going to have 2u minus 2, that's 0, 3v minus 3, that's 6v, equals 5. So we have 6v equals 5. So v is equals 5 over 6. That is, v is between 0 and 5 over 6. Since we have obtained our interval for u and v, we can now evaluate our integral. And we already obtained value for dA, which is this. So now we can do our transformation from xy to uv plane. And we already given that x is this, 2u plus 3v, and 2u, and y is 2u minus 3v. So when we add these two guys together, that will be 2u plus 2, that's 4u, 3v minus 3, that will vanish. So we have double integral, we have 4u, and our dA, we've obtained it here, which is 12 du dv. Which is 12 du dv. So when we multiply it together, we're gonna have, which is double integral 48u du dv. And our interval, we already obtained interval for u, which is this guy, and v, which is this guy. So we're gonna have, for v, we have 0 to 5 over 6, and for u, we have 0 to 5 over 4, 0 to 5 over 4, 48u du dv. So we can now integrate with respect to u. So we can take 48 out as a constant. We have 48 here, 0 to 5 over 6. That will be u square over 2, evaluating from 0 to 5 over 4 dv. So this is 2, this is 48. That will be 24. 0 to 5 over 6. So from this guy, we're gonna have which is equals to 48 is 48 over 2, that's 24. 0 to 5 over 6. This is 5 over 4. When you plug it here, that will be 25 over 16. So we have 25 over 16 dv. If log is that will just vanish. So we have 25 over 16 and 24. We can take that out. Actually 4 goes there, that's 6. 4 also goes there, that's 4. Yeah. And let's say 2 goes there too. That's 3. We have 2 here also. So 3 times 25, that's 5. So we have 2. Integrating from 0 to 5 over 6 dV. When you do that also, we have 75 over 2, that is V 0 to 5 over 6. So we have 75 over 2 times 5 over 6. This is 0. So we now have 75 times 5, that is 375 over 12. And we reduce both sides by 3. We're going to have 125 over 4. So that's the final answer. So when we evaluate this guy with all these vertices and the transformation x and y, we obtain 125 over 4.